Hey guys, I had a little trouble when I was recording the first time, so I'm just going to jump right in with the same paper. But we're going to go through the problem number 28 on your Unit 4 test review packet. This is slightly modified from the 2013 AP exam for response problem number 1. I know it's a calculator problem because this is number 1. Remember, on the AP exam, number 1 and 2 are calc problems, 3 through 6 are not. So I've already done some underlining work, but I'll go through this again with you guys. Is on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a processing plant is modeled by this. So I've circled all these 3 pieces of information because they go together. Where T is measured in hours, and I go from time 0 to time 8. At the beginning of the workday, so T equals 0, the plant has 500 tons of unprocessed gravel. That's my initial condition, so I underlined it. During the hours of operation, the plant is going to process gravel at this constant rate of 100 tons per hour. So that processing, I boxed, that information goes together. So part A says find G prime of 5, using correct units, interpret your answer in the context of the problem. Well, before I got started, I want to type my functions into my calculator. But because I'm going back and forth between pre-calc and calc, sometimes my modes are all messed up. So I like to clear my calculator to get started sometimes. And I'm going to go through that with you guys because it's just a good thing to do if you're ever having trouble or you feel like your answer isn't right. Sometimes you just might have something wonky on your calculator, and resetting it can help that. So if you want to reset your calculator, you're going to push the second button. And then down here on top of the plus side, it says MEM for memory. So if you do second mem, you get this list of options. It's best to go down to, so you're going to go down to reset. You can clear just your RAM, but I normally go over to all memory, and then I reset from there. Because I reset these calculators regularly, mine will go pretty fast, but if you haven't done it in a long time, it might take your calculator a little bit more time than it takes mine, and that's normal. So there it is, it's all done. So I'm going to go into my y equals now. I'm in radians because when you reset your calculator, you're in radians. And notice I have cosine, so that's going to be important. So if your calculator's in degrees, make sure you change it. So G of T is going to be 90 plus 45 cosine X, or T squared divided by 18. Close my parentheses. Make sure that typed in right. Okay, and then my second rate is actually just 100. It's just a constant value. A lot of times you can do work with that by hand, but it's helpful just to have it in Y2. So there's that. Okay, so it says find G prime of 5. Well, if I want to find G prime of 5, I'm going to do the derivative of G prime, which I have in Y1. If it's helpful, you can say that this is Y and this is Y2. So I'm going to go to Math 8. I'm going to take the derivative of G of T, which I have in Y1, so grab that. And I want to evaluate this at x equals 5 or time equals 5. Make sure you don't put x equals x. We only do that when we were graphing, but now we want to add a value specifically at 5. So there's my value. So negative 24. Remember, when you have something that you can round, so in this case, you could leave your, I'm sorry, you can't see. You can leave your answer as 24.587. That's truncating. Well, in this case, we could round up because there's a 5 here, so or we could leave it as a 6 there, or sorry, as an 8 there at the end. Either of those are accepted. I typically round, but if you left this as 587, that would be fine as well. Okay, so there's that. Using correct units, interpret your answer in the context of the problem. Well, notice we just did the rate of a rate. So if we have tons per hour, it's the change in something over change in something, so we're going to have an additional hour unit in the denominator. This is going to be tons per hour squared. Okay. So let's think about what this means. Notice that I have a derivative that's negative. That means something is decreasing. Well, the derivative we took was of G, so I'm going to explain what G was and then say that at that moment, that value is decreasing by this. So using correct to interpret the answer. So I'm going to say the rate at which unprocessed gravel arrives at the plant at time 5 hours is decreasing by 24.588 tons per hour squared. So let me talk about some of the key information that I have in here. What is decreasing? Well, G is, and G is the rate at which unprocessed gravel arrives. So I'm saying the rate at which unprocessed gravel arrives, so G is by this amount. I don't have to say decreasing by negative because I'm using this word decreasing. It's already implying that it's going to be negative. I have my units, and then I also need to tell when this is happening. Specifically, this is happening at t equals 5 hours, and I want to include that time unit in that as well. So those are the key things I'd be looking for. Again, the explanation of what G is, that it is decreasing at this value, and when this is occurring at time equals 5 hours. So let's start at part B. Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. So notice it's asking the amount that arrives over a time period. All I want is my change here. So I'm going to do an integral. Arrival is G of t. And I want during the hours of operations, what they said is from 0 to 8. So I'm going to plug that right into my calculator. Here we go. And I'm going to type in math 9. I'm going to go from 0 to 8. This was in y1 dx. And there's my answer. In this case, rounding and truncating will give you the same answer of, I'm sorry, I know it's a little hard to see the calculator. This third digit, it doesn't matter if we round or truncate, it'll be 1. So my value is 825, 551. Ask for units, so I would not give your units, but if you did have to give units, I think it would just be gravel. Or tons of gravel, I should say. Okay, so let's go into part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? Show the work that leads to your answer. So we can't just give an answer of increasing or decreasing. We have to justify a response, and specifically they're asking for work. So let's give a numerical justification for that. So the amount of unprocessed gravel. In class a lot, we said, well, let's just write an expression for the amount at any given time. So if I want the amount at time 1, 2, 3, whatever, that will be my x value. We started with an initial value of 500 tons. It's arriving at this rate. But we're going to put an x here because we're going to say we don't know what's for any given time. We could say after 1 hour, after 2 hours, after 3 hours. And then we're subtracting out the amount that's getting processed. And I believe that's just 100. I still need to put that dt here at the end. Well, if I want to know if this amount is increasing or decreasing, I know I have to know if its derivative is positive or negative. So now I'm going to take the derivative. The derivative of this is 0. The derivative, I'm going to plug in that x. So I'm going to have g of x minus, this is just going to become 100. There's no place to plug in that x. It's just going to be 100, okay? Well, we want to specifically know if it's increasing or decreasing at time t equals 5. So let's plug in 5. Remember, G is in y1, so I'm going to do vars, y-vars, y1. When I want to plug in a value, I need to put parentheses. If you just put times 5, that's not going to work. You want to say, this is function notation. I'm plugging 5 into y1, and I'm subtracting 100. So you'll notice that the rate that it's arriving is at like 98 tons of gravel per hour, but it's leaving at 100. So we can tell that the amount's going to be going down, the pile gets smaller because the amount that's being processed is greater than the amount that's arriving. So this value here was negative 1.859. So I can say the amount of unprocessed gravel is decreasing because minus 100 was negative. Now there's a couple different ways you could write this. You could say because G of 5 was less than 100. Because we've defined what A is, technically I think we can just say because A prime of 5 is less than 0, but I would use the information they gave you. I want to talk about the information that they've talked about, which is G and the 100, that rate of 100, okay? So part D says, how many tons of gravel are at the processing plant at time 5? Well, we now have this great statement for how much is at there at any given time. So the amount will be 500 plus the amount arriving in that 5 hours minus the amount being processed in that 5 hours. And I caught my mistake, 1 second. This thing here shouldn't be an X anymore, that should be a 5. because we're actually evaluating at 5. One thing to remember when you do use function notation, make sure you're consistent. Notice I have a 5 here, so everywhere there was an x should now be filled in with 5. Okay, so now I'm going to type that into my calculator. So I have 500 plus math 9. I'm going from 0 to 5 of g minus math 9, 0 to 5 of 100 dt. And there is my answer. It didn't ask for units, so I'm just going to leave it as a numerical value. If they did ask, be careful because the units weren't gravel, it was tons of gravel, so you'd have to use tons. So this is how many tons are at the processing plant at time t equals 5. Okay, so that's this problem. I hope that was helpful. I'll see you guys soon for the test.